Hi everyone, welcome or welcome back to my channel. In today's video, we are going to solve a question of binary search, that is split array largest sum. So first let's see what question says. So we have been given an integer array and an integer k. We have to split this array into k non-empty subarrays such that the largest sum of any subarray is going to be minimized. So, if you guys remember, we have been solving two questions of this category. First one was aggressive cow, and then yesterday also we solved a question of, I think, book allocation problem. So, this is also a similar pattern problem where we have to maximize a particular minimum value or minimize a particular maximum value. So, whenever the question has this keyword, we can always think about the binary search and answers approach. So let me just try to do a dry run. Suppose we have been given an array like this, which have these values 1, 2, 3, 4, and 5. And we have been given the value of k as 3. So what it means is that we have to split this particular array in three subarrays in such a way that first of all we have to find the possibility that which one is getting the maximum sum, which subarray is getting the maximum sum, and among that we have to return the minimum one. Okay, so for example, here are main now the previous two questions which we were solving, first one was aggressive cows, where our main target used to be the distance. Okay, there we have to maximize the minimum distance, and here it is saying that we have to basically minimize the largest sum. So here the target should be sum. It means we have to focus on how we can optimize the sum, right? So we can say, or you can we can assume that let's say our at most sum is going to be 10. Why at most sum? Because here it's saying to first of all you have to find the maximum sum, largest sum, and then we have to try minimizing that. So minimizing part will be taken care of by the binary search, but first we have to find the largest sum, right? So first we are just assuming that let's say I'll keep a bar for myself that I can assign each subarray at most 10 values. Like at most, basically the sum should be at most 10. Okay. So first, let me just remove these things. Uh, okay. So first, let's say we have been given these values. We have taken a subarray and we'll start asking ourselves that can we assign this value, this one to this subarray? Then we notice this one is not greater than 10. Okay, so we can assign it. Can we assign 2 inside it? So 1 plus 2, that comes down to 3. So 3 is also less than 10, which is inside our capacity, so we can assign it. Now we'll ask for 3. 3 plus 2 plus 1, that is equals to 6. This is also less than 10, so we can assign it to the first subarray. Now we'll come to the fourth element, that is 4. Okay, so this is going to be exactly 10. Okay, so this is sort of reaching our capacity. So if we are going to move towards the next element, that is 5, we'll know that okay, this is exceeding the capacity, so we'll need some other subarray to assign this element. So we'll create one more subarray. This is basically our subarray plus plus. One more subarray is added to the club. So here I'm going to add my next element, that is 5. Now our target was that we have to rearrange the element, or we have to assign these elements into the 3 subarrays, right? But here you just notice that we were able to assign in 2 only. But if you notice this situation, that we were assuming to have the capacity of at most 10 sum. Okay, means the capacity was at most 10, means 10 से कम भी हो सकते हैं, right? So we can try to cut down these elements. Like for example, we could also do this, that if 10 is the maximum capacity, we can also do that. Okay, we can consider, let's say 1 plus 2 in this, then 3 plus 4 in this, and then some other elements in the next one. So it means if this is able to pass, or this is able to satisfy our condition, the value less than 10 will also be able to do that. It means this is a final, this is basically a possible scenario. Now, if you remember the question, it was saying that we have to try to minimize the maximum sum, right? So, suppose if we got a possible scenario, possible sum as 10, so our binary search will tell us that we should try to shrink our capacity. So, let's try with a smaller value than 10. Let's try some other value, or let's say 8. Okay. So, again, I'm removing this. Then okay, so again we're going to ask the same thing. Can we assign 1 to this subarray? Yes, we can. Can we assign 2 to this subarray? Yes, we can because sum is 3, that is less than 8. Can we assign 3 to it? Yes, we can because sum is going to be 6. Can we assign 4 to it? Now, when we are going to add 4, the sum is going to be 10, which is not less than 8. So we have to take another subarray. Let's take another subarray. Okay. Again, we'll start from the next element because till this index, till 3, it has been taken by the first subarray. Now from the next subarray, we're going to assign with the next element. So can 4 come to this subarray? Yes, we can add it because 4 is less than 8. So I'll write it down here, 4. Can 5 come to this subarray? No, it cannot because 9 is greater than 8. So again, we are going to take one more extra subarray. Then inside this, we are going to ask, can 5 come inside this subarray? Yes, it can because this is less than the capacity which we have. So here we can see that we are able to split this subarray into the required amount of, basically we can split this array into the required amount of subarray given in the question. So we can conclude that 8 was also able to satisfy our criteria. Now, if 8 was able to satisfy it and we find the minimum value, we have to minimize our answer. So we should also try with some number less than 8, right? So let's try with number 5. Okay. So again, I'm going to remove these two subarrays. Then I'll ask from my first subarray, can I put 1 inside you? Yes, we can because 1 is less than 5. Now, can I put 2 inside this subarray? Yes, we can because 3 is less than 5. Can I put 3 inside it? Now, whenever we are going to put 3, the sum is going to be 6, which is greater than 5. So it will say that no, it's greater than the maximum capacity. So please go and take some next subarray and assign it to that one. So this is the next subarray, and I'll again start from the next element. Till 2 it's done and dusted for the first subarray. From this, for the second subarray, we're going to start from this index. Second index basically. So here I'll ask it that can I assign 3 to it? It will say yes because it's less than 5. Can I assign 4 to it? No, I cannot. Because if I assign 4, again the sum is going to exceed its maximum capacity. So it will say that please go and take another subarray and hand it over to them. So this is my third subarray and I'm going to ask it, can I assign the value 4 to you? It will say yes because it's less than 5. Can I assign a value 5 to you? I cannot because summation is going to be 9, which will exceed my maximum capacity. It means it's saying that the maximum capacity which you have assumed here, that is 5, it's too less. So please try to increase your capacity. Okay. So now we are going to try with some another capacity that let's say 6. Okay. So again, let me just remove these things. Again, I'm going to ask my first subarray. Can I include this first value to you, that is 1? Yes, I can. Can I include the second value to you, that is 2? Yes, I can. Can I include the third value, that is 3? This is going to be 6. So yeah, we can include it because it's equal to this capacity. Can I include the value 4? No, I cannot, because then it will become 10 and that's going to be greater than 6. So it will say that please go and assign that element to the next subarray. So here I am taking my another subarray and I'll start my iteration from the next element, that is 4. I'll ask it that can I assign 4 to this? It will say yes because it's less than 6. Can I assign 5 to this? No, I cannot because it's going to exceed my maximum capacity. So again, it will say, please go and take the next subarray. So this is the next subarray and I'm going to start from the next index, that is 5. I'll ask that can I put my this element inside it which has the value is 5. It will say yes because the value is less than maximum capacity. So we can say that we were able to arrange the element, or you can say we were able to split the array in such a way that basically all the elements were divided into 3 subarrays, which was the required amount in this test case. So why we are using binary search here? Now, let me tell you one thing. We had to minimize it, right? So initially when we took the value 10 and we figured it out that okay, we were able to satisfy our condition when we took the maximum capacity as 10, we were automatically able to eliminate all the numbers that comes after 10, because we knew it that if 10 is able to satisfy the condition, then the numbers like 11, 12 and greater than 10 will automatically be able to do that. But we had to find the minimum value. So we kept on shrinking our capacity. We kept on shrinking our search space until and unless we reached on value 5 and we realized that this condition was not, or basically the this assumptions was not satisfying the condition. So then we tried to expand it a little bit. This is what binary search does, right? Until we reached our optimum value, that is 6. So let us start writing the code for this. So here, if you guys are thinking that in binary search, array should be sorted, here we are not going to take this array as a range. I'll tell you what we are going to take and why. So very first of all, let me just declare our start and end. Start and end is basically the range from where it's starting and now in this question, since we have been told that this array is given and we have to split this into k number of subarrays, right? Now suppose we have assumed these assumptions which we were talking about here, right? Suppose this assumption, let's say we have taken as 3. Just assume we have taken it as 3. Then do you ever think so that the element 5 can be fit inside any subarray? No, we can't, because if the maximum capacity is 3, how we can fit this number 5, right? So it means our range should start from the maximum element of the array. I repeat once more. Suppose if, let's say, the range, we are basically traversing across our range, okay? So if inside our range any number is present which is, let's say, less than 10, suppose it's 5, okay? It means we are only going to assign those sum to the subarrays which is up to 5, not greater than 5. So this value 10 could not be assigned to any subarray, which should not be there because we have to split this array somehow. So it means the start should always be the maximum element of this complete array, right? Now if we come to the next variable, that is the end, how we'll decide that what could be the maximum value of the range. Suppose if we would have been given the condition that only we have to split this array to one subarray and we have to find the largest sum, what could be the possible answer? That put all the values inside that subarray, right? Putting all the values means calculating the sum of the array and putting it inside the subarray. So that's going to be accumulate of. Now here we have declared our starting and our ending, and then I'll be declaring a variable where I'll be storing my answers. Now this is going to store it in what manner? Let me tell you. Now here, whenever we were assuming now, and suppose our condition was satisfying, our assumptions were satisfying the condition, then we were moving to the next value. Then we were thinking, okay, now that's okay, this is a possible answer. Now we should shrink our search space. So when we realize that this is a possible scenario, then and there we can also store it inside our answer. So for that, I've initialized it. Then I'll write our binary search code. While start is less than equals to end, it is going to be start plus end minus start by 2. Now, the logic which we have discussed here, right? Like we were traversing across this array and we were checking that if we can put, for each element we were checking, right? If we can put this element inside this subarray or not, if we can put the next element inside the subarray or not. So the entire calculation, the entire logic will be performed by a function. So if that function is true, suppose this, I'll declare a function here. Now if this function is going to be true, what we were doing, we were storing it inside our answer variable, and then we were told to shrink our space. Shrink our search space means end is equals to mid minus 1. And if it was not a possible solution, for example, when we took the value 5, we realized that it's not satisfying the condition. Then we tried to expand our capacity, right? So we did s is equals to mid plus 1. And at the end, we'll be returning our answer. Now, let me keep the name as it is possible, which is going to tell me whether this scenario is possible or not. So first, let's write the code for this function. This is going to return me true or false, so bool is possible. Parameters, I'm taking this nums vector along with our main thing, that is mid, and then we'll be having this k also. Okay. Now what we'll do, okay, so let me also declare it here, nums mid and then k. So what we were doing here, let's try to tally it from the dry run which we did. Initially, I just removed all these two extra subarrays, okay? I started from the first subarray. I went on the very first element. I asked myself, if I'll go to add this inside it, is sum going to be less than the assumed sum? We were asking this, right? In this scenario, the assumed sum is nothing, but this is our mid value because we are using binary search. So we are going to declare this pages is equals to 10, so 0. Then so this is basically sum, right? What I've declared. No. In sum is equals to 0. Then we can say int subarray is equals to 1. Because initially we have taken the subarray by default. Okay, that's why. Now we're going to run a loop for int I equals to 0. I less than nums.size I plus plus. Then we'll check if sum, it means whatever sum we have in this subarray plus the next element which we are going to take, if that is going to satisfy our current condition, then it's really good, you can add it on. Otherwise you have to take another subarray. So if sum plus nums of I, if this is less than equals to mid, then it's really good, you can carry on, you can do sum plus nums I. Otherwise you have to take an extra subarray. Along with that, what we were doing, after taking an extra subarray, we were setting this value. It means suppose we were iterating from 1 to 2 to 3 And then when we came here, our iterator, it basically started from this index only. So it means we'll reset our sum variable to nums of I, because the elements before that are already assigned to the previous subarray, right? And here we're going to ask us one more thing, that let's say if our subarray at any point, for example, there was a scenario when the value we took was 5, right? So subarray was exceeding 3. So if any scenario came here where subarray is going to be greater than k, then we'll return false. Otherwise, we'll return true. Okay. Okay, so all the test cases are passing. Now let me tell. So this was all about it. Now let's discuss about its space and time complexity. Talking about space complexity, we are not using any additional space as such, so that's going to be constant. We go of 1. And for time complexity, our range is going to be lying between the maximum element and the summation of the entire, element of the array. And along with that, here also we are running a loop for basically n times. So we can say if this sum is s, let's say, and this is the maximum element, right? So we can say it can lie between uh, time complexity can be bigger of n into n log s minus this max, because this is the range for our binary search and this n is basically we're iterating it n times, that's why. So I hope you guys understood whatever I tried to explain. Thank you for watching. Bye.